Here we're going to learn about pyramids. So a pyramid has some sort of shape on the bottom, and we have triangles going around the outside connecting at that peak at the top. That's what a pyramid looks like in general. We could have different shapes on the bottom, but for right now we're only going to be dealing with square-based pyramids. So that means this shape on the bottom will always be a square for this year. They're really connected to rectangular prisms, which really you're just thinking of as just a normal box. So I want to throw that in here too, just to see how these two things are related. Right now we're just going to be talking about volume, just like we did for cones, but we also need to talk about the surface area of these square-based pyramids. So for right now, let's just deal with the volume and really how they're related to a rectangular prism. So rectangular prism is length times width times height, or you see the second equation, we have that capital B times H. That capital B stands for area of the base. So the base is just the shape on the bottom here, that's a rectangle. To find the area of that rectangle, you would do length times width. That's the base. Really, that's all that's happening here. We're replacing that L times W with this B. In general, you're not going to use that bottom equation. You're really just going to stick with this one, the top one, length times width times height. I think the second one's mostly there just to make the connection between this equation and this equation. You can see that's very similar to the relationship between the cone and the cylinder. It's the exact same thing, except for the 1/3 part. You can see that's exactly the same thing that we saw with the cylinder and the cone. All right, so first let's just find the volume of this prism. We're going to do length times width times height. It really doesn't matter which one's the length, width, and height. You could rotate this box and it would look different, but it's still going to have the same volume. I'm going to say that's my length, so I'll say L is 10. That's my width, and that's the height. So we'll do 10 times 3 times 4 to find out that that has a volume of 120 cubic inches. Hopefully that feels like review. You're just multiplying length times width times height. Pyramids are going to be new for us, so I'm going to go over really what that equation's saying. It's actually the same thing that I described here, though. That capital B, big B, still stands for area of the base. And like I said, it's always going to be a square on the bottom. So to find the area of the base, you could do the side squared, or I always just do length times width. On your formula sheet, you'll see S squared, which means you square one of the sides. I don't like trying to decide whether it's a rectangular or square, so I just multiply length times width each time. It's really the exact same thing. You just multiply the two side lengths. You multiply that side times that side. Since it's a square, you're just squaring that number. It's just that side squared. Again, that's the area of the square on the bottom. The H always goes straight up and down, from the peak straight down to the base. That's our H. The L, going down the slanty side, is a little bit different. We're going to use that for surface area, but not for volume. This H always goes straight up and down through the middle of the pyramid. So, in this one, in example 2, 8 is the height. The only other letter we really need to define is that capital B. We need big B times H there. So we need those two letters. We got H. Capital B stands for the area of the base. So we want to find the area of the square on the bottom. To find the area of a square or rectangle, you multiply the length times the width. So that's 10 times 10, or 100. So big B is 100. H is 8. I'm going to use Desmos like I did with our previous topic. I'm going to type 1/3 times B times H, and then just define each of those for Desmos. B is 100, H is 8, and so the volume of that shape is 266.6 repeating, And we're talking about centimeters squared there. Oh, sorry, centimeters cubed there because we're talking about volume. All right, so what do we notice about these volume formulas? So it's going from B times H to 1/3 of B times H. That's the only difference. That 1/3 is being multiplied times that. Just like with the cone and cylinder, the volume of the square-based pyramid is 1/3 the volume of the rectangular prism. 3 of those pyramids would fit inside of a rectangular prism that looks the same, that has the same dimensions. All right, so you need to be comfortable with this part where you need to solve for one of these numbers. This one was directly given to us. This one was not. You have to solve a problem just so you can plug in that answer into your equation. Really similar thing is going to happen on this next one, except we're going to need to solve 2 problems before we plug our numbers in. Volume is 1/3 big B times H. We're going to need to figure out the area of the base, and we're going to need to solve for the height. We don't know either of those 2 numbers. Right now we don't know the height, and we don't have the area of the base. Let's do the area of the base first. That's the length times the width. Length times the width for the bottom, or 20 times 20. That equals 400. That's the area of the square on the bottom. The height cuts straight through the middle of the pyramid. It's that length. We have the slant height here, but we don't have the straight up and down height. But you can kind of see what's drawn in the middle of that pyramid. We have a right triangle right there. I'm going to redraw that just so we can see it clearly. We don't know this yet. We don't know the height. We know that this is 16.4. That's the slant height. And we actually know the bottom side, even though it's not directly given to us. If this is 20, going all the way across is 20. Halfway across is going to be 10. It's kind of like the relationship between diameter and radius. Diameter goes all the way across the circle. This is just halfway across, so that's 10. And I'm going to subtly change this to a b so that I can plug this into a squared plus b squared equals c squared. We're using Pythagorean theorem to find the missing side of a right triangle. So I'm going to say 10 squared plus b squared equals 16.4 squared. I feel pretty confident that we know how to use Pythagorean theorem, so I'm going to kind of speed through this part. And I'm actually just going to do it in one line. I know I'm going to end up squaring these 2 numbers, the 10 squared, 16.4 squared, and subtract them. And then I'm going to do the square root of that number. I'm going to do all of that in one step. I'm going to do 16.4 squared minus 10 squared and do the square root of that number, all in that one step to find out that the height, really, b in the triangle is 13, or the height of my pyramid, going straight up and down there, is 13. So I have the area of the base. I'm going to change my area of the base to 400. I have the height. That's 13. So my volume is 1,733.3 repeating. And I cannot read those units, but it's going to be those units cubed. That's meters cubed. So that was a little bit involved. We had to find this number, and we had to find this number, just so that we can plug into that equation. So you have 2 problems inside of that bigger problem. Same thing each time. I would write down the equation just so I know what I need to find. I need to figure out my b and my h here. The h one actually is a little bit easier on this one. It's going straight from the top down to the bottom. 15 is the height there. And then again, b stands for area of the base, so it's the area of the square on the bottom. And it looks like they're only giving us one side there, but they tell us that it's a square base pyramid, so those are both 16. That's a 16 by 16 square. So to find the area, we do length times width and get 256. for the area of the base. So my area of base is 256. My height is 15. So the full volume is 1,280, that looks like inches cubed. So each time you're going to have to solve for a part of this before you just plug into that equation. All right, now we're going to move right into surface area. So we talked about volume of cones now and volume of pyramids. We haven't talked about surface area yet. Surface area is just the outside of the shape. It's talking about the surface, and it's talking about the area of that surface. So it's the area of all of the faces of a figure. When I say a face, I just mean like a side of a figure. So that's a face, that's a face, that's a face. It's just one of the faces, one of the sides of that shape. Surface area is talking about the number of little squares that are needed to fit or cover a figure. It's literally talking about the number of squares that fit on a shape. So we can hear the word cover, wrap, paint, material needed. All of those are talking about the outside of the shape. Material needed maybe is a little bit more vague. If it's talking about making the outside of the shape, then that's talking about surface area. It's possible you're talking about making the entire thing, which would include the inside. That would be talking about volume. The units are always square units. Unit squared. Again, it's actually talking about the number of little squares that fit on a shape. And then there's a lot of real-world scenarios that actually have this as an application. Labeling a can, tiling or carpeting a floor, wallpapering. You're all talking about covering a shape, wrapping a gift, wrapping the outside of a gift, or painting a room. It's talking about the surface on the outside being covered by something. I do need to talk about this picture. This is called a net. It's basically just a shape that's been unfolded. This started out as a cube. We took that cube and unfolded it, and now we can see all 6 of those sides. That's what a net is. It's just unfolding a shape so you can see all of the sides. All right. Just quickly, we're going to review finding these missing measurements. So on surface area especially, you need to find some missing measurements. There's 3 different numbers that we need for this equation. You're going to need to find all of those on some occasions. This first one, we're just looking at finding the height. Actually, this is what we did for volume. We're thinking about how to find that straight up and down height. So I'm setting up a right triangle here. The first picture I think was pretty convenient because it told us, it actually showed us that picture. It was basically like this, where you see that triangle very clearly. This one, I don't see that clearly. It doesn't even look like that's really a right angle, but it is. Going straight from the peak down to the center, that is going to create a right angle there. I'm going to draw that triangle outside of the pyramid just so we can see it clearly. I see that 6 is going down that slanty side. And then 5 is going all the way across there. So 5 goes all the way across there. This is only halfway, so that's going to be 2.5. That's 5 divided by 2. So I have C. Let's say that's A, and I want to find B, or I want to find the height of that pyramid. So we're going to do 2.5 squared plus B squared equals C squared, or 6 squared. I'm going to go back to Desmos, and Desmos is really convenient because all I really need to do is just change those numbers. I have this from before where I had C. In this case, that's going to change to 6. And I had either my A or B, so I subtracted them. Here I'm going to change that to 2.5 and find out that the B, or the height of that prism, sorry, pyramid, not prism, is 5.45. That's the straight up and down height cutting through the middle of that pyramid. On the next one, we're finding the lateral height. I've been calling this the slant height. Lateral height probably makes more sense because it's labeled as L. I just like calling it the slant height because it's going down the slanty side. So I'm going to draw that triangle outside of there so I can see it clearly. I see 24 is the height. I don't know L yet. I know that 16 goes all the way across here. It's the entire distance across. That's only going halfway, so half of 16 is 8. Now I can substitute my numbers in, A squared and B squared, and I don't know my C yet, so I'm going to leave that by itself. So it's a little bit different from the last two. where we're subtracting. On this one, we're actually going to add. We have the A, we have the B. So we're doing 8 squared plus 24 squared, and that equals 25.298. I'm going to round that to the tenths place and say that's 25.3. That is the slant height there. Pythagorean theorem is going to be really useful to find either the height when you're using volume or the slant height when you're finding surface area. All right, let's talk about this equation before we jump into this. It is a square-based pyramid still. So the shape on the bottom is a square. L, I think, is the easiest one for us to define because we've talked about it a bunch of times already. That I'm going to call the slant height. In your picture, it's very clear. It's not going through the pyramid. It's going on the edge of the pyramid along this side, along that triangle. So L goes down that slope. P stands for perimeter. It's written on your formula sheet. At the bottom of your formula sheet, there's that little key that says P means perimeter. In this one, it's not really clear what we're finding the perimeter of, though. These are both talking about the same thing. P and B are both talking about the base. P is talking about the perimeter of the base. That means adding up these 4 sides. So that's the perimeter of the base. B is talking about area of the base. Please write these 3 down. Define each of those in that space on the sides. That's going to be really useful. L could be given to us. P and B are almost never given to you. They'll tell you one side, and then you need to find the perimeter by adding up those 4 sides. They're going to be the same, or just multiplying times 4. And you'll need to find B by multiplying length times width to find the area of that square in the bottom. All right, let's look at that first problem and see what we're given. So 6 is going down the slanty side. That's good because that is our slant height. Now we need P and B. So P is the perimeter of the square on the bottom. Again, it's a square, so all of these are the same. There are 5 going all the way around. So the perimeter is 4 times 5, or you could just add 5 times 5 plus 5 plus 5 plus 5, and you get 20. The perimeter of the square base is 20. The area of the square base is length times width. We want to find the inside area. You multiply length times width, and we get 25. I'm going to use Desmos for this part too. I'm going to change my equation to the surface area equation. 1/2 LP plus B. My B on this one is 25. My L is 6. Whoops. L equals 6. And P equals 20. So I have my expression to find the surface area. And then I defined each of those for Desmos. I said B equals 25, L equals 6, P equals 20, and that tells me my surface area of that figure is 85. Now we're talking about area, so our units are squared here. When we're talking about volume, they're cubed. When we're talking about area, they're squared. All right, same kind of thing. I just want to define each of these, L, P, and B. I'm going to figure out each of those and then substitute them into the big equation. So my L, I don't have that on this one. I'm looking for that side for L. I have the straight up and down height, and I have the base of that triangle, but I don't have the slant height there. So I'm going to set up that right triangle. I know that my height is 15. The bottom side is halfway across. The whole way across is 16. Halfway across is going to be 8. Now I can find C there. 8 squared plus 15 squared equals C squared. So we could do that in Desmos. Actually, we already have it completely set up for Desmos. Actually, I think that was still 8. That changed to 15. This is really just showing what I did before to find out that C is 17. So that's C in the triangle, and really it's L in the pyramid. P stands for perimeter of the base. That's the perimeter of the square on the bottom. So I'm adding 16 plus 16 plus 16 plus 16, or 4 times 16, to find out that the perimeter of the base is 64. The area of the base is going to be length times width, which is 16 times 16, or 256. So my base is 256, my length is 17, and my perimeter is 64. So that has a surface area of 800. Again, we're talking about area, so the units, whatever they are squared. And we got 2 more. I want to show you an example of a net, and then this one's a little bit different, so that's going to involve more problem solving. For right now, we're just looking at this net where it's unfolded, and we still need to define, we're still finding surface area, so we still need to define L, P, and B. L is the slant height. If you imagine folding that back up, this 10 is going down that slope side. It's going down the side of one of those triangles. That is the slant height. P is the perimeter of the base, adding up 1, 2, 3, 4. 4 times 12 is 48. And P is the area of the base. That's length times width, or 12 times 12, which is 144. So I'm going to substitute each of those in now. 144 for my base, 10 from slant height, 48 for the perimeter. So that has a surface area of 384, I think it's centimeters squared. Last one. We have a square base pyramid. The square base pyramid, square base of a pyramid, has an area of 81 centimeters squared. So that's the area of the base. That's saying that B is 81. I'm actually going to draw that picture too. I'm going to draw that square and label that as 81 inside. That's the area. Slant height is 7. What's the surface area? So we really just need one more part to that. We don't know the perimeter yet. We know the base area. We know the slant height. We don't know the perimeter. But we're going to be able to find the perimeter just based off of this number. If that's the area of a square, that means we found that by multiplying those two side lines together. We multiplied x times x to get 81. We multiplied some number by itself. We squared some number to equal 81. This is kind of like the end of Pythagorean theorem. When you want to get rid of the squared part, you do the opposite of that. You're going to do the square root of that number. Those operations cancel each other out, and that's solving for x to find out that that side length has to be 9. It's possible you didn't need to go through that. You might have seen this already. some number times itself to give us 81. It's got to be 9 times 9. Those are both 9. That's the side length of that square. That's important because that's going to help us find the perimeter. If that's 9 going all the way around, 9 plus 9 plus 9 plus 9 is 36 for the perimeter. And now we have one last step, plugging into that final equation using a slant height of 7, base area of 81, and a perimeter of 36. So surface area of that one is 207 centimeters squared. I know this is long, but there was a lot to each of these problems. Hopefully it made sense. If not, rewatch, ask questions, practice until you get it.